Hello students, welcome back to our channel. Today we will see that how to draw this type of graph, and using this graph we will check whether this function is on onto or not. So at first just pause the video and you should try yourself, then I will help you. So start. Okay, now the function is given if x is box x plus 1 fractional part of x plus 1. So first of all we have to know that what is a box x, that is greatest integer function, and what is fractional part of x. Okay, first of all we will discuss about these two functions. These two function is very important in many questions. These two function will be uh, in in the question papers. These will be in complicated form, like sine of box x, sine of fractional part of x. Okay, so you should know the functions and their graphs. So first we see what is the greatest integer function box x. Okay, so greatest integer function box x is defined in such a way that in an interval 0 to 1 it will be 0, and in the interval 1 to 2 it will be 1, and 2 to 3 it will be 2, and it will go so on. And for the negative part, from minus 1 to 0 it will be minus 1, from minus 2 to minus 1 it will be minus 2. Okay, so the graph of box x will look like this. From 0 to 1 it will be 0. So from 0 to 1 this will be like this. Suppose this is 1, this is 2, this is 3, 4, and this is 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 1, minus 2. And from 1 to 2 it will be 1. So this is my 1. From 2 to 3 it will be 2. So this is 2. From 3 to 4 it will be 2. From 3 to 4 it will be 3. And from 0 to minus 1 it will be minus 1. Okay, so it will be like this. And from minus 1 to 2 it will be minus 2. So as we can see that this function graph looks like stairs. Okay, so that's why this function is also called as step function. Okay, between any interval from 1 to 2, 2 to 3 it will behave like a constant function. Okay, so we are now clear about the function box x. Now we will see what is the fractional part of x and what it look like. So now we will draw fractional part of x. Fractional part of x is defined in such a way: x minus box x. So if I take a number x equal to 1, then it will give 1 minus box of 1. What is box of 1? Is always 1. So it will be 0. If we take fractional part of 1.5, then 1.5 minus box of 1.5. So 1.5 minus 0.5 minus 1, sorry. So it will be 0.5. And what will be 1.9? Similarly, it will be 0.9. And what will be fractional part of 2? 2 minus box of 2. As box of 2 is 2, it will be 0, but box of 1.5 is 1. So we, for this case, we will have this only fractional part. 1 point, from 1.5 we will have 0.5, from 1.9 we get 0.9, and from 2 we have 0, and from 1 we will have 0. So this function only gives the fractional part of this number, so that's why this function is called as fractional part of x. Now we will draw its graph. So as we can see, from 0 to 1, fractional part of x, from 0 to 1, fractional part of x act like x, from, because from 0 to 1 box of x, from 0 to 1 box of x is equal to 0. So from 0 to 1, is, since box is equal to 0, it will look like y is equal to x. So this is 1, this is 2, 3, 4, 5. From 0 to 1, it will act like a straight line. But at the point x equal to 1, it will be 0. Okay. Now, from 1 to 2, from 1 to 2, box of x equal to 1. So, from 1 to, it is from 0 to 1. Now, from 1 to 2, since box is equal to 1, this function will be like this, x minus 1. And just look at this, y is equal to x minus 1 is a straight line, okay, and its slope is 1 and y-intercept is negative. So this will be look like this. Theta must be 45 since slope is 1. Y is equal to, just you should compare, y is equal to mx plus c, and c is negative, so it will cut y-axis at below x-axis, okay. And similarly, from 2 to 3, we will have y is equal to x minus 2. So this part is also look like this for the positive parts. Okay. Now we will check for the rest negative part. If we take for the negative part, just look at this side. If we take x in the interval uh, minus 1 to 0, minus 1 to 0, then this is y is a fractional part of x. Look, fractional part of x, this function look like this, x minus box x. Since in this interval minus 1 to 0, in this interval, what is box x? Minus 1. So it will be look like y is equal to x plus 1. Okay. And in this interval from minus 2 to minus 1, box x is also minus 2. So it will look like y is equal to x plus 2. All these are a straight line. So from 0 to minus 1, from minus 1, 0 to minus 1, this is a straight line. Its slope is 1 and y-intercept is positive. So the graph, and x equal to minus 1, y is equal to 0. X equal to minus 1, just from look at this graph, at x equal to minus 1, y is 0. So we have to start from here and see slope is positive 1, theta must be 45 and y-intercept is positive, so it will cut x is y-axis upward. Okay, so this graph will look like this, and y is similarly for y is equal to x plus 2, this is also a straight line with slope 1. So once again theta is 45 degree and x equal to minus 2, y is 0. Now one thing is that at x equal to minus 1, at x equal to minus sorry, at x equal to minus 2, this is 0. So and after that it will act like a straight line. Okay, so this graph will look like this. Once again, at x equal to minus 2, this graph will be 0. Now we already know we already learned the nature, behavior, and the graph of box 6 and fractional part of x. Now, using these two graph, we will finally conclude the graph of fx. Okay, and I hope you all have already written all these things. So, in the final part, just so fx is like this. So, we can write fx box of x plus 1, and we write fractional part of x is like this, x minus box x plus 1. Now just we will use this interval to sketch its graph. The domain of the function is from 0 to 5 by 2, that is 0 0.2.5. We will take only these values, okay, to draw the graph. So from 0 to 1, first we will draw the graph from 0 to 1. So x uh, at 0 to 1, box x is 0. From 0 to 1, box x is 0. So in place of boxes, we can put 0. And from 0 to 1, as we already told you, know that uh, 0 to 1 y is fractional part of x looks like x, a straight line. So from 0 to 1, it will be 1 by x plus 1. Okay. From 1 to 2, box x is 1, so it will be 1 plus 1. Okay, box x will be 1, so it will be 1 plus 1, and like this. And from 2 to 5 by 2 means 2.5, it will be 2 plus 1 x minus 2 plus 1. So finally 1 by x plus 1 from 0 to 1, and 2 by x. So this is my y, 2 by x from for 1 to 2, and 3 by x minus 1 for 2 to 2.5. Now finally we are in the stage to conclude this graph, and we will now draw its graph. So suppose this is 1, this is 1.5, 2, 2.5, 3, 3.5. Okay, and this is 1, this is 2, this is 3. Now look, from 0 to 1, this graph of the function is y is equal to 1 by x plus 1 from 0 to 1. So this is a hyperbola, and x equal to 0, just put x equal to 0, y will be 1, and as x tends to 1, y will be half. So half will be there, just let half will be there. So as it is a rectangular hyperbola, this graph will be look like this. Suppose half is here, y is equal to half. So it will be a rectangular hyperbola. Okay. Now when the range is from 1 to 2, So y is equal to 2 by x. It's also a hyperbola. Now at x equal to 1, at x equal to 1, just put x equal to 1 here in this function. We will have 1 plus 1, 2, fractional part of 1, 0, 1. That is at x equal to 1, it is 2. So this graph will start from this point, and as x tends to 2, it will be 1. So this graph will look like this from 2, from 1. This will be at x equal to 2, this will be 1. And from 2 to 2.5, at x equal to 2, just put x equal to 2. So this is 3 and this is 1, 3. And as x tends to 2.5, that is 5 by 2, it will be it will change to 2. So the graph will be look like this. It starts from this point 3, and that is as it is from tends to 2.5, it will goes to the point 2. So this is the graph of these fx. Okay. Now there is another important point, that as we can see that at the point 1, this function is discontinuous, because the functional value at x equal to 1 is 2, but the limit at 1 minus is half. Similarly, the function is discontinuous from 2 and 3, 2 and 2.5. Okay, 2 and from 3. The graph is not here, so we don't need to tell about this. Just we will tell the function is discontinuous at x equal to 1 and x equal to 2. Now, to check whether function is 1, 1 or on 2, just using this graph, just look one thing. There is another theory. Okay, just I am telling you this theory, that a function fx will be 1, 1 if for any two distinct points we will have two distinct values of fx. If any two distinct points give same values of fx, same value of fx, this function will be not 1, 1. So in that case, the graph will be look like this if this is not 1, 1, because if we draw any parallel line, then it will cut x-axis at two distinct points. But suppose this parallel line is y is equal to alpha. So at these two distinct points, x1 and x2, this function fx is giving same value alpha. So it cannot be 1, 1. So to be a function 1, 1, it should be either 1, 1. So either increasing or it will be either decreasing, because in that case, no line parallel to x-axis can cut the graph to more than 1. Okay, and for onto to check onto, just look one another geometrical interpretation for onto. Fx is onto when if its range set is equal to its codomain. Okay. Now a function will be onto if we draw any line in this codomain, then it will must cut the axis, cut the curve. Okay, that means if a function f is defined, suppose from R to a b. Okay, so this is my a and this is my b. Okay, now if we have this graph like this, uh, like this, and if we draw a line just parallel line to the x-axis through the point B, we can see that this straight line does not intersect the graph y is equal to fx. This means that we can take any point from its codomain, but we cannot have a pre-image. Okay, so the geometrical interpretation of onto is like that, that we can draw any parallel line through its codomain, and if it cuts the graph somewhere in this interval, then it is onto, because in that case we can say that suppose this is fx, it will cut the graph at this point, so we can say that for y is equal to b, we have a pre-image here, and suppose this is alpha. Okay, at that point we can say that if alpha is equal to b. Now look, between half to 3, if we draw any line just horizontal to x-axis, parallel to x-axis, it will cut the graph exactly at one point. Okay, just draw any line parallel to the x-axis, it will cut the end from half to 3. Any line will cut the graph somewhere in this interval, so f is onto. Okay, so f is bijective. So without any calculation, just using this graph, we can say that this function is bijective.